Hi, hello. So in the previous video we have seen about the single phase rectifier. So in this video we are about to see about the single phase inverter. So first of all we can see what is my inverter. So power inverter. So the power inverter is a power electronic device or circuit. So that is able to change the direct current into alternating current. So in the rectifier is a vice versa of this inverter. So rectifier will be converting the AC into DC, whereas the inverter will be converting this DC into AC. So yeah, so the square waveform, sine waveform. So let us check the output with the help of MATLAB. Let us open the MATLAB. So similar to rectifier, in the inverter also the same procedure. So once the MATLAB window opens, you can open new Simulink model. So inside the Simulink model, we can create a blank model. Yes, blank model. So once a blank model is open, we can import the components which we needed for doing this simulation. So the blank model has been opened. So let us import the components which we need. So first one is DC voltage source. So make sure you are selecting the voltage sources from power systems library. So DC voltage source. Next thing is IGBT. So with diode we are taking. Can rotate and keep. So here also we have no need of measurement port. So we are disabling measurement port. And making it as a 4 copies of diodes. Then collector to collector, emitter to emitter, voltage source. Yes. So next thing is RLC. So place the RLC in between the two legs. So make it as resistive load. For measuring this, we need a voltage measurement. So the voltage to be measured is across the load. For visibility, we are using scope. So here also for scope, we can use 2 inputs. So configuration 2, layout 2. Okay. For measuring input, we are using additional scope in input. Yes. So this scope will be now showing the input voltage and also the output voltage. So the next major part in this inverter is the pulse generation. So for a controlled inverter, we need a pulse. So for pulse generation, we are going to use sinusoidal pulse width modulation, so that we can take a sine wave, and a sawtooth generator. Make sure you are taking from power system library. And for comparing this, we are using a add from this thing, the same add. It should be compared with the sawtooth generator. Make it as plus, minus, the same thing for second, plus, minus. So here we have to go compare to 0, make it as greater than or equal to, and connect to first thing, The same thing for second case. Yes. So now this will be a one signal. This is your second signal, but here you need a 4 signals. So use a logical operator and make the logical operator to NOT gate, because we are going to give the 2 signals in the same link. So we can yes. So in order to reduce the confusion, here we are going to use from and go to tag. So here go to, this is your first signal, so make it as S1, second S2, S3 and finally S4. So S2, S3 and finally S4. So connect these things. Yes. Now here we have to fetch a signal from here to there. So we have to use from. So this is S1, S2, S3 and then S4. So S1, when S1 is switched on, S2 will be on because we are using a NOT. So here we have to use a graphical user interface, GI, make it as a. In the sine wave, there is a modification you need to give. In sine wave, it can be time, amplitude, everything, no problem. The frequency is 2 star pi star 50. This thing no need of change. Okay. In second, frequency 2 pi 50. Here the phase in terms of radian is pi. Okay. Yes, we hope we have completed everything. So now we can run the simulation. The simulation is done. You can check the output. So this is your input DC supply. First given auto scale, expanded x-axis. So here you can able to see a sinusoidal, that is near sinusoidal waveform, because an inverter will be converting your DC supply into a pulsating DC. By using the additional filters, you can make this as a perfect sinusoidal waveform. So this is a complete setup of a single phase inverter. So in the upcoming videos we can look into the 3-phase rectifiers and then 3-phase inverter. Thank you.